The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to this live learning event entitled Systematic Approach to Controlling Infiltration with Chemical Grout. My name is Don Rigby, Director of Marketing for AVANTI International, and today I have the greatest job in the world. I get to introduce you to some pretty savvy people and facilitate a session to maximize the next 60 minutes for you. Now, the Triumvirate is a name I affectionately extend to three independent companies who come together annually and in the name of education. ARIES, Logiball, and AVANTI are independent, yet they are codependent in support of public works and contractors who serve municipalities. Collectively, they've made a difference for hundreds of communities in the battle against, you guessed it, infiltration. Folks, the platform we're using today keeps us all in mute mode, at least you as participants on mute, but it's very important that we become interactive, and here's how we get it done. You're going to have questions. I encourage it. In fact, we'll reserve time at the end for Q&A, but I recommend as questions come to mind, immediately type them into the collapsible dialog box on the right-hand side of your screen. And I'm the only one who sees these questions. I have the option to interrupt the presenter at that given time or save it for the end. But I can tell you, if we don't get to all the questions in this webcast, we'll certainly answer every question individually by email, and that is a promise. I am officially the clock watcher of this event, and I respect your time. I want to make sure we complete this event in 60 minutes so that you feel good about sharing this time with us in future webcasts. And one last bit of information. There will be 3 interactive poll questions asked during this session. These are very interesting because I get to play back the answers right away. So let's do the first one. And the first one's going to be easy. There we go. I see in some action people filling out the information. Thank you very much. I'm not going to let it stand too long because I want to keep moving and get closer and closer to this subject. We're about 70% voted. I think I'm going to close the poll and then share it back with you right away. The results I'm seeing is that we have a high degree of public works people on board this presentation, and that's perfect. Perfect. I am welcome to everybody, regardless of your role and responsibility. Let me introduce you to our experts today. Mark Achtel is the president of Logiball, a design and manufacturing firm of tools and devices to the trenchless industry, including the renowned Test and Seal Packers. Daniel McGill is the president of AVANTI International, the leading producer of chemical grout, engineered to stop leaks, stabilize soil, and control groundwater. Dick Shantz is an engineer. He's a process engineer by training, a project engineer by function for ARIES Industries, who is a leading manufacturer of inspection and rehabilitation solutions for underground infrastructure. And to start us off, Mark Achtel of Logiball opens with the truth about I&I, and more specifically, infiltration. And Mark, if I do this correctly, I think I could change you into presenter, and we'll lead with this one idea that you're pretty dedicated to creating these tools to help people solve this problem. Mark, welcome to the webcast.
Thank you, everyone, for attending. Just want to start it off here by making an inventory of what we have. There are over 5 billion feet of sanitary sewer pipe in the United States, and that is increasing every day. This represents a major investment on our part in municipalities and taxpayers around the nation. It is our responsibility to operate and maintain these assets in order to get the most out of them. These assets are too frequently associated with out of sight, out of mind. Okay? Here's a piece of pipe that's being laid. The pipe is only a part of the system. In order for the system to work correctly, the pieces of pipe have got to be aligned up together. Maintaining their proper working condition will extend their useful life. And having a proactive management and maintenance plan will also reduce the need for emergency responses when we have failures. Here's our sanitary sewer layout. We have our manholes, we have our main lines, laterals, transmission lines. All these are being directed at the treatment plant where they will be treated before they are released back into our rivers and streams. Well, in some cases, part of our collection system is underwater. And if water has chances to enter our collection system through the joints or laterals or whatever openings are there, we will get events like surcharges and SSOs. So what is infiltration versus inflow? Well, infiltration is basically groundwater, which is coming into our pipes and manholes and laterals, while inflow is more surface water entering the sewer via flooded sewer vents, sump pumps, manual storm drains, basement drains, and other means than groundwater. So in our sewer system, we have our manholes. Easily accessible, we can open them up, people can go down and fix these things. We have our joints, which allow groundwater to come in. Our service lines, which are basically the least accessible and which eventually contribute a lot of groundwater infiltration. So what's the problem with Y and I? Well, according to the EPA, infiltration and inflow represent almost half of all the flow at the treatment plants. So infiltration and inflow becomes a huge problem. It's our tax dollars at work, and it also means overflows can happen and basically damage the environment. Flooding of local sewage lines, streets, roadways. Okay? Increased cost of pumping and sewage treatment. When that pumping station's running 12, 15 hours a day versus 8 hours, it's money basically going down the drain. If that pump is also working 15 hours a day, that means its useful life will be decreased over time. Increased risk of SSOs resulting in fines. Depositing of fine soils resulting in reduced capacity of sewer collection system. As groundwater enters the system, so do some of the fines of the backfill. These fines coming in create areas of loose soils adjacent to the defects. So we're not supporting our joints or connections as we used to. Potential loss of backfill support for the pipes, which eventually can result in structural issues and failure of the pipes. So why control infiltration? Well, basically, first thing is to meet federal state regulations and avoid these SSOs. Reduce our costs in the operation and maintenance of these systems. Avoid man-made sinkholes and damage to transportation infrastructure and other infrastructure. And reduce treatment costs of the wastewater. No one likes to see their sewer bills go up. And of course, to extend the life of this precious asset. So what happens? Well, what we see here is we have a perfectly good piece of pipe. But unfortunately, we have a joint that's open or missing gasket or broken gasket, which allows that groundwater to enter the sewer system. In time, at stage 2, water has been entering and so have fine particles, creating just around the joint a small void. Then we start getting failures of the pipe, and as it goes on, we get total failure of the pipe. On the left here is a view of what we see with CCTV cameras. We have a circumferential crack, which is basically like a joint, which allows groundwater to come in. As this groundwater comes in, so do fine particles. And if you look at the picture on the right, eventually we get voids on the outside of the pipe. So it's not only the groundwater that we have to treat, but it's whatever's on the outside of the pipe. Here's a little exercise that we do at Grout School. Basically what we're doing is taking plexiglass pipe and filling about a foot with rocks and sand. And at the bottom we drill a hole 1/8 of an inch, which represents a very small leak. We then fill with about a foot of water above this and basically collect whatever's coming out. And if you look closely at the jar here, the bottom of the jar basically has sand, which comes in from this and 1/8 of an inch hole. So over time, we are creating situations which can lead to this. Sinkholes caused by erosion of the foundation of the streets. Okay, this is, I would say, a reactive and not a proactive maintenance. So how can I get the most from my investment? What do I need to do? What can I do? Well, we have options. Dig and replace, okay? Fold and form lining, sectional lining, pipe bursting, slip lining, cure-in-place pipe, or chemical grouting. Which one will stop the leaks? Well, first thing, what is chemical grouting? Basically, it's the ejection of two components, okay, that are pumped in and around voids, the pipe and manhole structure, to stop infiltration and exfiltration, stabilize the surrounding soil, stabilize the pipe in return, and seal annular space between the hose pipe and the liner. So with this, I'd like to introduce you to Daniel McGill, which basically breathes and thinks about chemical grout day in and day out, and someone that you can rely on for chemical grouting advice. Daniel?
Cool, thanks, Mark. Hopefully you guys can see my screen. We presenters are all over North America, so hopefully this technology is working just great. If I had 2 cups in front of me of chemical grout, both cups would look just like a cup of water. You wouldn't be able to tell the difference between the grout or regular water because there are no suspended solids in the grout. It's just a liquid that turns into a firm, solid gel in a predictable time frame, anywhere from 5 seconds to several hours, depending on how far you want it to permeate the soil around the pipe or around the manhole or wherever you're grouting. In fact, when they used the grout to encapsulate hazardous waste in Tennessee, they gave it an 8-hour gel time. So for 8 hours, it just permeated the soil like water and then became an impermeable mass that water couldn't penetrate. One of the slides that you brought up, Mark, the process of sewer failure, this is my favorite animated slide of the whole presentation because it shows really the whole process. Mark talked about why we want to grout, and I'm going to talk a little bit about when to grout and when not to grout. If you notice in stage 1, it's just the leak starting. This is the perfect time to grout. This is a perfectly good pipe. And if it's grouted now while it's leaking, this system will last decades and decades. And if in your city you're not air testing the joints, if you're only going off of visual, then you're doing a disservice. Because if you air test the joints, then you'll know if it's going to leak air, it's going to leak water eventually. Stage 2, you see that as the void gets bigger and bigger, you see deformation of the pipe. This could be grouted. It just depends on how deformed it's gotten. But if you wait in stage 3, now you can't grout, and you're forced to do another type of trenchless technology, which is to put in a new structure, a new pipe, either pipe bursting or digging up, something that's a lot more expensive than chemical grouting. This is my favorite image, and these 2 slides, the last one and this one, you'll probably see several times throughout this presentation. Hopefully they'll be burned into your memory. This really tells the whole story for me. This was just a couple of months ago in Washington State, I believe, and you can't tell from the picture where the infiltration started or where the void started, but when I look at that manhole, I look at the space where the pipe connection hits that manhole. I just wonder, however long ago, months ago, a year ago, had they taken the lid off that manhole, would they have seen soil and sand in there and known that there's a void being caused outside the manhole? They could have addressed it at that time. In fact, one of the photos that Mark showed of a huge SUV that went through a sinkhole, there were 2 manholes there as well. So I think that's a real significant point of interest. Something that this photo does for me also is it reminds me of the fact that it's a whole system that you have to stop the infiltration in. So you can't address only the main line. You also have to address the laterals and manholes and so forth. And even if the municipality says we're going to do lining of main lines or lining of manholes, you still have to stop the infiltration in order to put on that coating for the manhole or put on that liner. In this image you see a contractor, he's got resin-soaked oakum, and he'll stuff that in the joint, and as soon as the water hits it, it becomes very sticky and expansive and will seal that joint so that then they could put the coating on. Similarly, you could just drill a hole straight through the manhole and pump the same chemical that they use to seal main lines and laterals. You could pump it into the soil and encapsulate the manhole. It takes about 60 gallons of grout if you have a standard 10-foot by 4-foot manhole. So they're going to stop the infiltration here before they line it. If you're in a mainline scenario, contractors will often, before they line, they'll grout the gushers, the highly active leaks in the main lines, because that infiltration coming in could cause a bubble in the liner, which will decrease the capacity of the pipe. The municipalities don't want that for sure. And also cause resin washout, which will make the liner weakened at that point. So they may grout beforehand, and then after they're done lining, you'll see here, they could just grout these cracks at the lateral connection. In this case, the goal is to line, so they line, but then they have to cut a hole in that perfectly good liner. So water that's in the annular space between the host pipe and the liner now has an entrance point again. And so it gets back into the system. You can see the red arrows. Hopefully they're moving on your screen to show the water entering from the annular space. So they can position a packer over it, and the grout, because it's the same viscosity as water, it has a centipoise of about 1.5, 1.2. It travels in the annular space between the hose pipe and the liner and cures, so it becomes a solid, and also goes out the cracks or joints into the soil on the outside. And that's really the goal. That's where you want it. There's, I guess, several myths about grouting, and one of them is that the grout only seals the joint itself, where the red circles here are, only an inch or two. But the reality is the contractor should pump enough grout to get it into the soil. It's really a soil sealing process. It fills all the voids between the gravel or the sand and creates what we call the gel soil matrix. Here's a grout donut that they dug up after 25 years. And this is what it would look like on the outside of the pipe, preventing the exfiltration of the sewage and preventing infiltration. This is a great image, and it's, if you can take that one and lay it over this is an animated version. You can see this is the completion of grouting the system. Maybe they started with the main lines here. You've got your grout donut, the lateral connection, several feet up the lateral. Usually it's standard to go 3 or 4 feet. There's a very well-known case study where they went up 38 feet up the lateral and sealed every defect in the lateral. And then also the manhole has been encapsulated, and rather than chase the water from crack to crack in the manhole, if they curtain grout it like this, then water can't even get to the structure, just like water can't get to the joint here. So much of this presentation is about sealing the entire system, and I'll introduce you now to Dick Schatz, who's going to talk more about it. If you don't know Dick already, he's a great guy to know at ARIES Industries. So Dick, take it away.
Thank you, Daniel. Let's see how well I do on this transition. Away we go. Okay, I'm going to spend a little time talking about the pipes. I'm asking you to think about the collection system either in your community or one that you're familiar with, and just begin to think about what it's like. If you look on the left there, you'll see putting pipe in maybe 50, 60, 70, 100 years ago. Basically 2 feet at a time, tar joint, great big hand-dug trench, filled up with gravel. Today we have longer pipe segments. You'll see them going together, but again, gravel to give you a nice slope so that you can drain. But this is the kind of thing that we're working in. 125 years, but just look at all the joints. If you keep going, if you really think about it, here's a 1991 EPA little sketch. But you'll notice that there's a massive set of underground pipes that make up our infrastructure. If you just look at the water portion, you've got the lateral, the service lateral from the house, you've got storm drains, you've got catchments, you have the sewer. The sewer is the lowest pipe in the system, okay? And it's a downward sloping pipe for sure. So it really forms almost a double drainage system. All of the dug trenches for all these others cross the sewer trench, and you get water draining through the soil. And if any of you have seen those charts of storm events, you'll see infiltration goes on for days at a time after a major storm event as the water works its way down into the sewer trench. You heard earlier 5 million or 5 billion feet of sewer pipe. Of that 5 billion, if you just look at the collection system alone, it's at least 1 billion feet for just the collection, not the services, not a lot of other things. But, 2 billion. If you take that and look at it, you're going to have at least 500 million vitrified clay joints had been poured prior to the 1970s. In the 1970s, we switched to a more modern synthetic rubber joints, and things certainly improved. But here you can see the old hand pour job going on, fill the pipe in behind it, pour the joint, move on. Literally, what you have here is you've got beautiful pipe, vitrified clay pipe will last 200 to 400 years. But your sewer won't last that long because your joints are going to fail. You lose your joints, you lose your sewer system, slowly but surely. Here we are pouring more joints. You'll notice sand on the outside, great big dug trench. This really whole thing creates an underground, you might call it French drain on the outside of the sewer pipe. So anywhere that there's a failed joint or a place for the water to enter, it'll enter into the sewer system. Here you see gravel is backfill. I'll take you back to this chart. Again, if you look up here at stage number 1, you literally have any place that happens to get water flowing through it, it comes in from the ground. Another way to look at it, though, what happens when this pipe gets surcharged in a storm event? The water actually flows out and can liquefy, literally liquefy the bedding soil around that joint, and when it drains down after the surcharge passes, it drains that soil along with the fines, and that really almost amplifies the decay pattern we see here. Literally, joint air testing and grout sealing is a solid, proven way to sustain your vitrified sewer collection system, because you've got to do something to those joints. You cannot line every pipe. You've got 2 and 3 foot long pipe segments, 8, 10, 12, 6 inch. That's the majority of your collection system. And those joints are every 2 or 3 feet, and therefore the chance of failure over time is extremely high. First 1 or 2, 3 or 4, but over time more will fail. So we talk about sewer system maintenance, okay? Well, it really is a 3-step process today, isn't it? You clean the pipes, you TV inspect, and you evaluate. That's what we probably have been taught to do. Every 10 or 15 years is what the theory is. I don't know if that happens in many municipalities. Sometimes I know they're going through for the first time. You can tell by the amount of solids coming out. Well, I had trouble here. I can't move ahead. Let's try down here. Okay. The next step we really have to look at is to air test all the joints. If you do a manhole-to-manhole run of about 300 joints, you basically have a situation that you're able to tell if 2 or 3 or 5 joints are failing or if none of them are failing. So that's an important step. Excuse me. If you're going to test the joint, it's very easy at the same time to grout the joints that have failed. So if you go into a line and you would test 100 joints from manhole to manhole, and you find 10, 15, 20 joints that fail, you grout them. You now have sustained that sewer system. Now you're able to write a meaningful evaluation of that inspection, because you did both the physical inspection for cracks and breaks, and you did the joint test, because you can't tell failed joints just by looking at them. you would say, oh, I see the staining, but you don't always see that staining. Okay, what is this thing, this test and seal process? We're going to talk about that next. Basically, people do things, but if you get a process going and a system, processes are going to get things done. And that's where the three of us have come together. Chemical grouting with AVANTI, Logiball with the tools, ARIES with the equipment, and you have an integrated process. So the test and seal program, if you're going to have a program in your community, it's basically a 5 steps that have to be taken to be successful. You've got a process. That's the grouting process. You have a system. Those are the tools and the equipment that make it happen. You have a procedures to be followed. Not just do it however the last guy told you. There should be a more organized procedure for carrying out the work. 4 records have to be kept. 10, 15 years from now, are you going to, or even shorter, a week from now or a month from now or 2 years from now, are you going to go in and be able to tell which joints were grouted and how much they were grouted and which joints passed the test, but 2 or 3 years later do not pass the test, have to be grouted. And the 5th part is education. With the turnover in people, both at community level and because of age, education is an important step in this whole process. Let's just talk about the process itself. One is air testing. We're testing the joints for watertight integrity. Stops infiltration and exfiltration. Both of those things are damaging to the backfill, and the backfill is what supports the joints. Originally, those joints, I'll just say, were some places no joint material at all. Then tar was used, or oakum, or whatever else they happen to have, cement. We grout the trench. You've heard that earlier. We're really not grouting the joint. We're not replacing the gasket. We're stopping the ebb and flow of water through the pipe joint. And lastly, we don't talk about it a lot, but during the grouting process, root control chemicals can be included in the grout mixture. While it may not stop roots, it will certainly retard them if you inject enough grout. And that's very important because if you have a root problem, roots really are very hard on sewer joints. Any little crack, a root will crawl through it. The system, it's basically an integrated TV, air testing, chemical pumping, injection. It's an equipment designed to arrive on a job site, a manhole, and achieve the desired results. The chemicals, they're designed and mixed to achieve that sealing objective in the environment they exist in. Underground, being diluted with groundwater or displacing groundwater depending on the situation. Test and seal joint packers. These are the tools, the actual tools that are located over the joint, and you've seen how those work earlier. Procedures. All these things fit together. Methods and specifications. Confirmation tests that the equipment is performing correctly, because the operator can't see the equipment. All he can do is watch his monitor, watch his monitoring equipment, meters, and gauges in his control room. The chemical mix confirmation. Is the grout mixed the way it should be, the way it was instructed by the chemical grouting company that supplied it? Test and seal. The results have to be confirmed. Is the joint in fact sealed after you would inject the chemical? And lastly, procedures require warranty testing. This is stuff that Mark, I think, touched upon earlier. It is part of the ICGA recommended standard. Record keeping, you're really talking about 2 types of records. One, you've got a grout mix data sheet. Here you keep track of the job, some information about the sewer, the packer to know how big the void is. What's the grout mix itself? How did you mix it? What was the chemical ratio? Did you mix that every time? Below the last one is you keep a running record of every mixed batch. The second thing is the sealing work, the actual joint data. You'll see there is the air test, the seal and pump. That's the grout pump. Pump to refusal. The ground won't take anymore. Cure time, retest. Standard procedure. A process leads to predictable results. That's the real message. Education. This has been a tough one. About 8 years ago now, we started, the three of us actually, AVANTI, Logiball, and ARIES, started the Grout Boot Camp. It's once or twice a year. We have anywhere from 15 to 30 people. It's a hands-on grout training course. We review the process, the grouting process. The specification requirements. We talk about the new NASCO ICGA spec, the equipment, operation and maintenance of it. This is all hands-on. Chemical safety, important step. Chemical mixing and testing, another step that isn't really common on many trucks. The tools, the grout packers and the ejection guns. How do you maintain those? How do you fix them? How do you make sure they're running right? And lastly, you've got the system integration. You put it all together and you show how it works. All right,
Dick,
Don, I think it's yours.
Yeah, I wanted to indicate that we're halfway through time-wise, and we've got a lot of material to cover yet, but I wanted to direct one quick question, and I think this should probably go to Daniel. It's November. I'm in the Northeast. Is there a seasonal aspect to grouting that I should be aware of?
Certainly grouting happens more in the warmer times, but grouting can be done all year long. It's just a matter of whether the ground is frozen. Typically 5 or 6 feet underground, the soil and the infiltration, it's not frozen, so it can be done all year long.
All right, let's go ahead and launch another interactive poll question here. I just love these. All right, what technologies do you currently use to control infiltration? In this case, I would encourage you to check all that you do. You may check more than one. It'll be interesting to see how we all fare here. And if you're an engineer, what do you recommend? If you're a contractor, what do you do? If you're a municipality, what do you support? I'm going to go a couple more seconds and then close it. And then share. I am seeing fellow presenters, if you can see this, I think you'll see where point repair, sectional liner, cure in place is tied for first place, chemical grouting second, followed by pipe bursting and fold and form. Sometimes our presenters can't see this, and this kind of hinges on what we do in the back end of the presentation. So duly noted. Thank you for your contributions here. I'm going to go ahead and hide this and recommend that we now talk about, I want to introduce Mark again, and because he is well suited to discuss the operating standards in our industry, because he is the chair of ICGA, and that being Infiltration Control Grouting Association, a division of NASCO. Mark, welcome back. Thank you for picking up on the next presentation.
Thank you. As in any process, an industry basically develops standards for its operational procedures. So in our industry, of course, we have standards for the, I'll call it the delivery equipment. We also need standards for the tools being used to fight this infiltration, and of course standards or repeated standards for chemical grouts being used. So the standards and best practice, well, they basically what they're doing here is giving us a pathway to success. That means that there has to be a minimum repeatable performance standards for all of these items, whether it be the delivery system, the chemicals, and the tools to obtain repeated success. So best practices are basically developed by industry experts in conjunction with these standards. So if I go back about 8-10 years ago, we're looking at standards that have been developed by some NASCO members back then, and went to ASTM, along with, of course, the ASTM group, and developed standards for mainline sealing of joints, for manhole sealing, and for lateral connection sealing. And as of recent effort by the ICGA along with NASCO, a new suggested standard specification has been developed as early as April this year, by the way, which you will get, I believe, a copy at the end. So all these documents refer to equipment or process that have to be verified before we go out and do some work. So in this case, for the tools, the work begins in an above-ground test in order to make sure that everything is working correctly, the integrity and performance capabilities of these tools. So basically, we have an above-ground test cylinder or PVC pipe, which is drilled, which has a pressure gauge and a valve to make sure that all the integrity and everything is for the testing equipment is working. So whatever we're seeing in the truck on the gauge basically matches what's going down here. All these are required in the ASTMs and in the NASCO specs. Another issue that we have to look at is the combined grout pump output. These chemicals are being pumped 1-to-1. So we do need to make sure that we are within a certain percentage that we are pumping 1-to-1. By doing this test, we're also measuring how fast we are pumping these grout out, which will be information that will be useful when we are deciding on the gel times. The other thing that we have to look at is what are we pumping? Okay? Typically, we're building 30-gallon batches, okay, which basically means a 20% concentration of solids in a 30-gallon grout tank. When these two are being combined, the AP or the SB side, it now becomes a 10% solids content. That's fine. That's a great starting point. In some cases where we have high infiltration or we're near a stream and we know we are going to get a lot of dilution, it may be considered to increase the solids content because the first few gallons of grout pump may be diluted. What do we need to know? We also need to know the packer of the pipe void. When you're pumping out there, the first thing that's going to be filled is the annular space between the inflated packer and the inside of the wall. And as you can see here is basically the green dyed material, and in this case is water. So now that you know how fast you're pumping, what's the void between the packer and the pipe, you can start playing with your gel time. Cup test. Well, cup test is going to be done to confirm these gel times above ground. This test should also be performed when there are temperature changes above 10 degrees Fahrenheit, when mixing new batches, or also the next morning. If the truck's been staying overnight and nothing's been done to it, we might as well check the grout in the hoses by recycling them first. So standards for sewer grouting. For years, this industry and technique, chemical grouting in sewers, has been referred to as an art and a science. Well, the addition of recent standards, best practices, specifications, and testing are turning this technology into more of a science. With this, I'm turning it over to Dick Shantz, a mentor and personal friend, and off to you, Dick.
Okay, I hope everybody's seeing this.
We're seeing it.
All right, we're in good shape. Okay. I'm going to talk a little bit more about a couple of things here, really the process itself. And the real message here is that, first of all, test and seal is a process system. If you treat it as a process and do it in a systematic way, it's going to yield predictable results. And that's really what you got to keep in mind, because as you could see from all the examples, this is out of sight. You really don't see what's going on. The chemicals are going out into the soil. You have very little knowledge of what's actually happening as you pump. And I'm going to touch upon that again. Here you see the packer. We see the chemicals coming out into the soil. Those chemicals are liable to do a number of things. First of all, there may be no soil here, as you saw in the example. So we end up with a void space that has to be filled with grout. And the chemical goes out into the soil. It does both. In the void space, there may have been water, so you may get an equal dilution, 50-50. In the soil, you probably will displace some of that soil. So there'll be both mixing and displacement. But that's what's happening, okay? To the operator, he mixes these chemicals in 2 tanks. Here's 2 really nice stainless steel tanks I'm proud of at ARIES. And of course, this is what a truck is more likely to look like. Lots of gear hanging all over the place. These guys go on the road, as you know. There's a lot to be done, but the operator here is just finishing his chemical mixing. He will do the gel test that Mark just spoke of. It's a very common test. You usually are generating a gel that's somewhere between 20 and 30 seconds for 8, 10, 12-inch pipe. But there's other things you can do. The next question is, how was it mixed? Did you actually have a full bag? Is the chemical behaving properly? Here's an operator using both a thermometer and a hydrometer. That's like you would measure the density of a battery solution. And with that information, you can actually confirm the solids content. The lower line is 20%. The middle red line is 30%, and the top line of kind of pink is 40%. Now that's what you would have in your grout tank. Easily done on a truck. This is the original data we actually took. We went all the way with working with AVANTI from a 10% solution to a 40% solution in the grout tank. And we monitored the specific gravity, that's this line here, versus the temperature. And you'll see it is temperature dependent. But these lines, as much as they are, you'll notice they're about 3/4 of an inch apart on a graph. It's very easy to take these readings. It looks like it's extremely precise, but any operator will be able to do that. In fact, this one operator that we were working with in these photos, he took great pride in that he could do this. He said, how often people ask me, what do you got there? What's your mix? He said, I don't really know. I just tell them I put a bag in and I put 30 gallons of water. But here you can see. Here's the second test we've been experimenting with. It's a force test. That little meter there is nothing more than a force gauge. That means it reads in pounds, and the bottom foot has a 1 square inch area. So when you push down, you basically have a reading of pounds per square inch. Simple way to get a reading. It's interesting if you noticed, but here I'll go back a minute. This reads about 5 to 6 pounds per square inch. That's pure grout, okay? Just pure grout of about 12% solids. You take and we mix that same grout with mud, and I mean it was mud, so we diluted it by roughly 50%. In other words, we now had a much lower solids level. And then it gelled, and you'll see here the force is up there around 15 or 16 pounds per square inch. Grout in soil is really much stronger than people give it credit for. This chart is just representative of how you could in your mind picture the grouting process. One, we have the term we call gel time, okay? This is in seconds. Across the bottom we have the percent solids in the grout. Remember Mark mentioned we mix 20, 30% grout in the grout tank, but when we then combine it with the AP tank, we end up with half that. So we've got somewhere around here, you can see anywhere from 4 to 12%. Let's say I started with a 12% mixture. This blue line, you read over this way, this is the gel resistance. This is the strength of the gel. Does it just fall like a glob on the table, you know, or does it actually stand up and have some body to it? That's always a hard term to determine, and that's why we went with this little force test meter. But you'll notice here, as we move ahead, and I'm going to move on to the next slide, we start out and we go from 12% solids to 10%. That's 16% dilution. We still have a good gel. There's nothing wrong with this range that it's in here. It comes down to the gel resistance drop from about 16 to 10. But you'll notice the gel time. Originally it was down here at about 17 seconds. It's now up to 30 seconds. This is what's happening outside the pipe if you've got active infiltration. Now we're diluted down here to 33% solids, or a third diluted. You'll notice that the strength of the gel, it's gotten more flexible, I'll just call it. It's not as well consolidated. It doesn't stand up on its own. It tends just to be very, would squeeze in your hand. You could move it a lot. You'll see also that the The gel time is up to 50 seconds. We're approaching a minute. If you keep going, and we go one more graph, we're down here now, 50% dilution. That's not uncommon at all. If you look at the soil, soil is about 50% voids. Around a sewer pipe, that void area is filled with water. As the grout comes in, it displaces it and it mixes. So seeing a 50% dilution is not uncommon outside the pipe. Now that's not right at the point where it's injected, but that's as it goes out into the soil. But look what happened to the gel time out there. It's up to 90 seconds. So you can see these two, you get a little feel for how these react. I'm not trying to educate you on the whole process today, but I am trying to say there is a technical basis for looking at chemical grout. Okay? So what do we have? We got an operator that you just see him as a strong arm, maybe on the back of the truck. He's really a very highly skilled person with a lot of capability. And here he is pulling his packer in at the end of the day, winding up his hose. And this is his office. This is his office. This is his control room. He's got two monitors. You can see the packer here. He has information on the screen, footage, the pressure. We call it the void pressure. Right here on this grout panel, here's the void pressure reading. Here's a timer, and here's the number of gallons pumped. Down here we have the discharge pressure of the two pumps. This is his home. This is where he operates out of. Okay? Daniel, I'm going to turn it over to you now.
Okay, great. Thanks. Hopefully you're seeing, I'll go through this fairly quickly so we have plenty of time for a question and answer period. When we do the grout schools, it's largely contractors who attend because it's very hands-on. But we always have inspectors and or engineers, and the biggest question from the engineers is about return on investment. And some of these we've covered, the benefits of grouting, because you're preventing flooding, SSOs, you're reducing EPA fines, you're preventing sinkholes and so forth. Keep in mind that what we typically tell the engineers is that the grouting and lining, for example, really work well together. They're not designed to do the same things. Lining is designed to be a new structure, create a new structure in a pipe, and grouting is not designed to be a structural fix. It's designed to stop the infiltration. In fact, all the other rehab technologies out there are about structural support. This is the only one designed specifically to stop the infiltration. But if a municipality wants to choose between one or the other, if you do a cost comparison between lining and grouting, if you're looking at an 8-inch pipe, grouting may be around $6 to $9 per linear foot to grout that pipe, whereas lining may be anywhere from $25 to $32. And I give this presentation all over the country, and I always ask, are these numbers accurate? And only one time someone in their specific region of the country said it's a little higher here. It got up to $35 per linear foot. So hopefully these numbers are accurate. If you have something different, let me know. If you look at the lateral connection, grouting a connection might be $350 per connection. If you put a T connection or do lateral lining or a top hat, you're looking at anywhere from, say, $1,500 to $7,000 per connection. So there's a big difference in cost, and I really want to emphasize that municipalities need to know that lining and grouting work together. You don't have to choose one or the other. This is a very well-known case study from the city of Sunrise, Florida, from 1992, and they were measuring flows at the pump station of 720,000 gallons per day. The city sealed 500 feet of 12-inch pipe. There were joints every 5 feet. They used 700 gallons of grout at a cost of about $6 per mixed gallon. So they spent around $4,000 on grout. They reduced the flow by 615,000 gallons per day, which would have cost about $1,300 a day to treat that. That's based on, in this city in that time, they were paying $2.16 per 1,000 gallons to treat the water. And so that equals about $1,300 a day. So the payback timetable, if you take the cost of the grout divided by the treatment cost per day, they made the money back in 3.8 days, and the city saved $480,000 that 1 year by using a chemical grout program. Many of you may be familiar with Dr. Vippu. He's the head of SIGMAT, the Center for Innovative Grouting Materials and Technology. He's the chair of the Civil and Environmental Engineering at the University of Houston. He's got a well-known white paper out. If you haven't read it, we can send it to you. Just let us know. And he concludes at the end of his paper, to date, the only proven method of stopping infiltration based on cost effectiveness and method of leak repair is chemical grouting. So I hope that answers some questions for you. Don, I'll turn it back over to you, hopefully for Q&A. I'm going to try to...
Daniel, I think I already got it. I think we're in business.
You got it. Okay, great. Perfect.
Thank you, Daniel. Before we open up to the Q&A, and if you haven't sent in your questions yet, please, now's an excellent time to do that. But permit me to highlight something we deem important. In the promotional announcements leading up to this live learning event, we itemized 5 takeaways that you would yield from this presentation. Above all else, I certainly wanted to make certain we delivered on this promise, and I add one more because the 6th one has been a topic of passionate debate internally, and I thought it was worth sharing with you. Dick, could you please respond to this question? Why underground systems attract groundwater?
Basically, they're designed to. Simple as that. There are a series of interlocking trenches. Gets into the bottom trench, which is the sewer line, and that groundwater just follows that sewer pipe wherever the pipe goes on the outside, looking for a way to get into the pipe, into the sewer system.
Great. Mark, our options for solving infiltration, what are they?
Well, I've talked about different options earlier that concerning structural enhancement or replacement of the pipe, but chemical grouting is one of these tools that work with the others hand in hand. But when the issues are solely infiltration issues and not structural, chemical grouting is still the best return on investment.
And Daniel, when does proactive maintenance beat reactive replacement?
The short answer would be always. It's always cheaper to maintain it than deal with an emergency after failure.
Yeah, well said. Dick, I don't think you can give me a short answer on this. What is meant by systematic approach?
If you follow a system, you're going to get predictable results. That's why. So a systematic approach is a documented procedure that you either know or you understand that you follow to get the end result.
Well done, Sarah.
That's it.
And Mark, who benefits from controlling infiltration?
Everyone. From the wastewater operator, the taxpayers, collection system managers, elected officials, everyone's safe. You know, you're addressing infiltration. You may not have to go and build a new treatment plant to accommodate all this infiltration going to the treatment plant or upsize it. You know, and you look at the reducing SSOs and quality of our rivers and streams and lakes, everybody's a winner.
Well done. And Daniel, this is the one we've had fun with all week. Can we eliminate infiltration or just control it?
Yeah, I think it's a great question, and my answer is yes, you can absolutely eliminate it. The key is you got to address it as a system. You can't just focus only on the main lines or only on the manholes. You've got to address all 4 points of entry and tackle it as an entire system.
Well done. We are now entering into question and answer. I've got 5 minutes left on the clock. This is going to be wild to try and get to most of these questions. And again, if I can't get to them, we will certainly respond to them electronically by email. But here's one I think that Dick can best answer, and this was phrased as $1 million question. After we complete a test and seal cycle, how many years until you repeat the process?
I think you would do it as part of a normal clean TV test and seal. If you're doing it every 5 years or 10 years or 15 years on your system, you're going to come back in that time and you're going to do it. You're going to test and seal the joints that fail, but you're going to test all the joints again, end to end, manhole to manhole. Clean, TV, test and seal, and then do your evaluation.
Huh. Well, this question may just tie right into that as well. And I'm thinking, Daniel, you might be the better source on this. What is the life expectancy on this work?
Well, the grout itself, the U.S. Department of Energy studied 7 different types of grouts in order to determine what they wanted to use to encapsulate radioactive waste. They gave acrylamide grout a 362-year half-life in the soil. So it wants to be underground in the soil. It'll last a long, long time. The question is really, was the work done properly and done well? Did they put enough grout outside the pipe into the soil to make a difference and to support the pipe bedding? So it's difficult to answer. We typically say if it's done right, it'll last the life of the structure, and that's our best answer for it.
All right, another question. How do we know where the grout is going? I would imagine that means after it's injected into the soil, how do we know where it is curing? And I'm thinking, Mark, can you answer that question?
Absolutely. The best way to find out first thing where it's going is to put a dye in the grout. So if it comes back into the pipe, you'll be able to see something unless you have a strengthening agent added to it. But the grout would always take the path of least resistance. So what is the path of least resistance once it's outside the pipe? No one knows. But that's why you're going to rely somewhat on pressure as measured down in the void, or as refusal to know when to stop pumping. And at a point in time, you may have to go to stage pumping, that is, pumping a certain amount, can't raise the pressure, let it set, pump again, trying to build layers of grout until you achieve a seal. Basically, someone's decided it's too much grout, there's something wrong back here. That's my answer.
Thank you. I'm seeing a lot of questions about, can I receive this PowerPoint presentation? Do you do demos in cities? And there's some really good things I think we can answer better on a one-to-one basis. What operator contractor certificates should we be looking for when selecting pre-qualified contractors? Great question. And Dick?
Okay, yes, I think I can answer that. I think there's two things you should look for. One is you certainly should make sure they have the chemical safe handling certificate. That's very important. The second thing is, I believe it's important that they attend some form of a grouting school and have a certificate confirming that they, in fact, participated and have passed through that education process.
Well done. I'm going to ask one more question on an interactive basis, and then I am going to move very quickly to recognize the time. I have just launched a interactive poll, and it looks like you are viewing this. I can't tell that by chance, but it looks like I'm asking you to, as a repair practice and rehab strategy, what's your perspective on chemical grout? And the answers are coming through, and I didn't expect this one to be as fast and as simple. You have to think about this a bit. And there's half of you have voted, more than half. Well, we're making good progress here. I think I'll go ahead and close this down and share with all. Presenters, I don't know if you can see this or not. It looks like yes. there's an openness to using chemical grout. There are some specialty contractors on board, and already chemical grout's a best practice. Good. We've got a nice mix of folks on this thing, and this has been a real joy for us. This is not something we're not. Let me minimize this a little bit. And took care of that. And as promised to everybody that there'd be a white paper we'd share with you from ICGA and the actual standards that Mark talked about in the first part on his second presentation. And these will be sent to you electronically. And we truly enjoy doing these things. And Daniel, Dick, Mark, if you'd like to offer some last minute exiting comments, that'd be great, because we're getting close to bewitching hour.
Well, this is Mark. I'd like to thank you for attending our first webinar, and I hope you found it interesting and educational. You know, chemical grouting is not the solution to all your sewer problems, but when it's applied correctly in the right environment, it's definitely going to help municipalities stretch out those rare rehab dollars. So thank you for attending.
This is Dick. I feel much like Mark. I really appreciate those of you that have signed up and gone through this. We certainly hope to do it again with other groups. And I guess, Don, this may be available for other people to use too, right?
Yeah, this is going to be recorded, and everybody here will have access to this recording for the course of the next year.
Good. So
Daniel?
thank you, everyone.
And yeah, thanks everyone. And if you know someone who should view this webinar, if after the recording, if they want to do it live, just let us know, and we can include them on the next announcement of our next webinar. We'd like to start doing these more often because they're such a great format to reach people. We've got people on the call here internationally today even, and so just let us know and we'll let them know so they can participate in the next one. Hopefully you've got 3 new resources that you can call on to ask questions, and certainly check out all 3 of the companies on websites or even YouTube and see videos of grouting and testing.
Yep. We absolutely love teaching what we know and believe about chemical grouting. The only thing we like better than webinars is teaching nose to nose and belly to belly. And there's a hands-on training opportunity in January that's been alluded to a couple times. It's at Avanti headquarters just south of Houston, where it's nice and warm in January. This ARIES boot camp includes all members of the Triumvirate on January 9, 10, and 11. And we'll send some additional information to you on that. On the way out, as you exit the webinar, you'll be asked a few questions. If you feel you were served well over the last hour, please let us know. We fully intend to be the best in the business of these live learning events, and your feedback will let us know how. So thank you very much. Until the next time, so long.
Thanks, Don.